Hello student, welcome to all of you in chemistry classes. Now today we study about the fourth collegative property, here called as the osmotic pressure. What? Osmotic pressure. Before the osmotic pressure we already study about what is collegative property, what type of collegative property at present. First is known as relative lowering of vapor pressure, establish a relation P naught A minus PA by P naught A equal to chi P and other. Second, elevation in boiling point, and established a last relation like a delta TB equal to KB into M. And we also study about the cryoscopic constant. Thirdly, the third collegative property, depression in freezing point. We also establish a relation delta delta TF equal to KF into molality. But not today. We study the fourth collegative property, that is osmotic pressure. But student, in this topic, osmotic pressure, firstly, to study about the osmotic pressure, one term must be very important. Without that term, osmotic pressure can't be introduced. That is known as osmosis. What? Osmosis. Certain idea about these things must be studied, student, in biology 9th and 10th classes in terms of water potential. But here we study this term osmosis and osmotic pressure in chemistry classes. So what is the osmosis and osmotic pressure? So this topic again now, like the all other collegative property, study also in a number of headings. You see firstly here written like a collegative property. And the fourth collegative property, that is osmotic pressure. It is denoted by here pi. In this topic we also have the number of steps, number of heading in which we study this thing. First you see here the definition. What? Definition. In this heading we discuss about the osmosis. Then one term must be introduced in that definition, semi-permeable membrane. Second topic must be osmotic pressure, which is the collegative property. Third, the figure representation. How can we more easily understand osmosis and osmotic pressure? Then here the fourth, you see here below the whiteboard, that is known as mathematical treatment. But actually we can say it like a Ventov equation for the dilute solution. And actually the Ventov equation of dilute solution, that is pi equal to CRT, derived by the help of three laws of osmosis. First, Ventov-Boyle's law, second, Ventov-Charles law, third, Ventov-Avogadro law. We actually give the mathematical treatment of osmotic pressure, that is pi equal to CRT. Next, we discuss about how can we say osmotic pressure is also a collegative property. And the last, determination of molar mass of non-volatile solute by using collegative property osmotic pressure. So these are the steps, heading in which study about the osmotic pressure. So firstly I want to move about the definition of osmosis. So before the definition of osmosis, firstly you listen to something carefully. What? One term must be studied in class 11, that is known as diffusion. So osmosis is also type of diffusion, but must be changes something on them. So we can say that when a two solution, one become higher concentrated, another become lower concentrated, is separated by a thin membrane. That thin membrane here given the name as a semi-permeable membrane. Or in another word we can say that when a pure solvent is separated from the solution. For example, we can say that when water is separated from sugar solution through a semi-permeable membranes. It observed that the solvent particles actually start to migrate from pure solvent side or from lower concentrated solution side into solution or higher concentrated solution through the semi-permeable membrane. So this spontaneous migration of solvent particle from pure solvent side into solution or from lower concentrated solution side into higher concentrated solution through the semi-permeable membrane is actually known as here the osmosis. Again we repeat. What? When a pure solvent is separated from a solution by means of a very thin membrane, here given the name as a semi-permeable membrane. It observed that solvent particles start to flow, migrate, move from pure solvent side and entered in a solution. That phenomenon here given the name as a osmosis. So you see now here the whiteboard. In the definition portion, we given here only one definition here. What? Osmosis. The spontaneous passage or flow of solvent from pure solvent side into solution through a very thin membrane here called a semi-permeable membrane and tends to dilute the solution is commonly known as here osmosis. What? Again we repeat. The spontaneous passage or flow of solvent particle from pure solvent side into solution through semi-permeable membrane and diluted it is called as osmosis. Another way, these are also stated like this. The spontaneous movement, spontaneous passage, spontaneous flow of solvent from lower concentrated solution side into higher concentrated solution side through semi-permeable membrane and tends to dilute higher concentrated solution is also called osmosis. So these are the concept about your osmosis. You also see in everyday life this phenomenon, but we doesn't able to know about what is the name of that phenomenon. Actually, when gram is taken in water, that means when gram is taken or kismis is taken in water, sometime later we feel that gram or kismis must be swell up. Why this must be happen? These are nothing, these are a osmosis process. The number of things must be present here. This type must be happen when we in the morning actually given the water in a tree or different plants. That plant also observe the water molecules from the soils in which we given the water. That phenomenon, that place is also called as the osmosis. That place is, we can see that that vegetable membrane of that plant or tree act as a semi-permeable membrane, and from water side, that means from soil waters move through this vegetable membrane into what? The plants, and they becomes like this. So these are the concept about your osmosis. So after the definition about the osmosis, the one thing must be here. That means when gram is taken in water, they start to swell up. This process must be begins only, doesn't end. No. We to observe that sometime later, they even disperse in water, no changes must be taken place. Why? That grams not more swell up. Actually, that swell up not begins more is done by the help of osmotic pressure. That means when solvent from pure solvent side start to migrate and entered in a higher concentrated solution, that higher concentrated solution from the beginning start to stop the entering of that solvent particles on them. But in the beginning they are unable to them stop, but at those state they must be able to stop the entering of that solvent particle into solution. That time a pressure is developed over the semi-permeable membranes, actually by the higher concentrated solution, to stop the entering of that solvent particle into solution through the semi-permeable membrane is given the name as a osmotic pressure. That means, very simple, we can say that those pressure actually build up over the solution at the semi-permeable membranes toward the lower concentrated solution or toward the dilute solution to stop the osmosis, that means stop the entering of solvent particle into solution is actually given here the name as a osmotic pressure. So we feel that you must be understand these things. So here you see the one definition according to these things. What you see here, the osmotic pressure. Then we discuss about another term, semi-permeable membrane. You see here one definition is written here. We already explained them. The pressure developed on the solution sides due to net flow of the solvent molecules through semi-permeable membrane is called as osmotic pressure. You see here again, the pressure developed, exerted or offered on the solution side due to the net flow of the solvent molecules through semi-permeable membrane is known as osmotic pressure. So another number of definition must be present. What is the more definition about them? The number of another definition present like this. That means the excess pressure that must be applied to a solution to stop the passes of solvent molecules through semi-permeable membrane into solution. That means prevent the osmosis is actually here given the name as a osmotic pressure. Again we repeat the another definition. What is another definition? The excess pressure that must be applied to a solution to stop the passes of solvent molecules through semi-permeable membrane into solution is known as osmotic pressure. Another language we can say that those pressure always offered by higher concentrated solution at semi-permeable membranes towards the pure solvent to stop the entering of solvent particle from pure solvent side into solution is also known as osmotic pressure. Remember it. That means again we say the pressure build up after the net flow of solvent particle from solvent side into solution over the solution to stop the osmosis is known as osmotic pressure. So you see again this definition, the pressure exerted, developed or actually offered by higher concentrated solution on the solution side due to the net flow of solvent molecule through semi-permeable membrane is called as osmotic pressure. It is denoted by pi. What? It is denoted by pi. You see here, osmotic pressure denoted by pi. Now, these things also explain here in the heading of third figure representation. You here see two beaker. In the same beaker, one line here given by the red. These are semi-permeable membrane. Two figures are present here. One becomes before the osmosis and second after the osmosis. You see here, in firstly the before the osmosis, a container is taken, must be separated through a thin membrane here, the red line. One consists about the pure solvent, another consists about the solution. Another language we can say that one consists about the lower concentrated solution, another consists about the higher concentrated solution and separated by this semi-permeable membrane. You see here the solvent molecules here indicated by the arrow. The solvent molecules from pure solvent side start to entering into solution through this semi-permeable membrane. This movement of solvent particle from pure solvent side into solution here given the name as osmosis. We also written below the figure movement of solvent particle from pure solvent side into solution through semi-permeable membrane is known as osmosis. So these are the concept about the osmosis. So you must be remembered on the basis of figure diagram. For example, more easy standards. Suppose that in pure solvent side only water are present and the solution side we take in the sugar solution and separated by the help of this semi-permeable membrane. What happened? Water start to migrate from pure water side into sugar solution side through this semi-permeable membrane and diluted them is known as simply osmosis. In this figure you see two capillary tube in both sides must be added. we want to explain by the help of these things as a osmotic pressure. So you now see in the second figure, which is after the osmosis. You see here the after the osmosis phenomenon. We already explained the one level of liquid must be down up and another becomes upward directions. These are indicated also in the capillary tubes. What happened? After the osmosis, you indicate here the certain arrow developed through the solution side over the semi-permeable membrane into the pure solvent. These arrows are actually here the solvent molecules again tends to enter in solution through the semi-permeable membrane, but a pressure developed here, you see in a blue color, a pressure must be developed here over the solution side indicated by the blue arrow. The pressure actually offered by this solution over the semi-permeable membrane to stop the entering of this solvent particle into there and stop the osmosis, here given the name as a osmotic pressure. You see here these things. Here the solvent molecules again tends to migrate from pure solvent side into the solution. But here you see in a solution side in blue color and arrow, a pressure must be developed or pressure developed by the solution over the semi-permeable membrane to stop the entering of this solvent particle into solution, here actually given the name as osmotic pressure. So we again repeat and given the one definition below this figure, the pressure build up on solution, okay, on solution, a pressure or pressure exerted by a solution on semi-permeable membrane toward pure solvent after that was due to net flow of solvent from pure solvent side into solution to stop the osmosis, here given the name as a osmotic pressure. Also you study in class 11 in physics the concept about the pressure. That time P equal to rho GH must be denoted. So we also want to explain these things by the help of this figure. So these are the differences. Here the issue is the two levels are similar, but here one must be down, one must be actually with the upward direction. So these are the differences. This height must, that means difference of the level of the two liquid are indicated here by the H. And you see here we indicated the arrow. These are indicated like a pressure developed to stop the osmosis. So here given the name as osmotic pressure. So similar like the P equal to rho GH, here we can see that pi equal to rho GH. What is pi equal to rho GH? Like a P equal to rho GH, where rho is the density of the solution and here G acceleration due to gravity, and this H we already say the difference of the two level of the liquid after the osmosis. So like the pressure pi equal to rho GH, later we discuss here the pi indicated by the CRT. So these are the concept about your what do you mean by osmosis, what is the concept of osmotic pressure, how can denote it, and how can we explain these things by the help of graphical representation. So one thing more before we close this topic in first part, we discuss these things in the next part, but before the close these things we want to discuss about the one more thing, that is mathematical treatment. We actually given the name like this, the Ventop equation for the dial. Observe that osmotic pressure of a solution is directly proportional to the molar concentration. What? Osmotic pressure is directly proportional to the molar concentration. Actually here the molar concentration of solute present in that solution. Another language we can say that osmotic pressure is directly proportional to molarity. But so you see here the one things more in mathematical treatment, this Ventop equation for dilute solution for the mathematical treatment of osmotic pressure on the basis of experimental truth, pi equal to CRT. You see here pi equal to CRT, where pi is the osmotic pressure, C with the concentration of that solute in solution, R with the universal gas constant, and T is known as temperature in Kelvin at the whole process must be done. So pi equal to CRT is their mathematical treatment. But we also know the one thing here. C, we know that C equal to N by V. That is here written V. That N means number of mole of the solute. So according to this relation, this equation must be like this: pi equal to NB by V into RT. Hence, we can say that here they becomes like the pi V equal to NB RT. Remember class 11 state of matter. Remember here the class 11 state of matter. Pi V equal to nRT. So these relations are also present, but in a different form. Pi V equal to NBRT. Pi with osmotic pressure, V with the volume, always taken in a liter. NB the number of mole of the solute, R with the universal gas constant, here taken 0.0821 liter ATM per mole per Kelvin, and T with the temperature, always in Kelvin. So these are the mathematical treatment about osmotic pressure. But before we close, you see the one things quickly, and then we discuss the next class. Actually, these equations is derived by the help of three laws of osmosis. That means this Ventop equation for dilute solution, which are also called as the mathematical treatment of osmotic pressure, is derived by the help of three laws: law of osmosis, Ventop-Boyle's law, Ventop-Charles law, Ventop-Avogadro law. But these things we must be discussed in the next class. So these are the concept about what do you mean by osmosis, osmotic pressure, what is their figure representation, what is their mathematical treatment. But one thing must be left here. So quickly we given the one definition and close this topic quickly. What is this? Semi-permeable, SPM. So here on during this discussion, one term number of time repeat that is known as semi-permeable membrane. What is semi-permeable membrane? So students, simply we can say that these are very thin membrane which only allow, that means when a solution is separated from pure solvent, or when a lower concentrated solution separated from a higher concentrated solution. So this thin membrane which only allow to migrate the solvent particles or their ions from them, but never allow to passes or migrate the solute particles, is known as semi-permeable membrane. So what you see again here, the semi-permeable membrane indicated here the figure, semi-permeable. This membrane, those thin membrane which only allow the solvent particles or ions to migrate from them, flow from them, but doesn't allow any way to movement or migration of solid particles, is here given the name as a semi-permeable membranes. So they must be the various example of semi-permeable membrane. All vegetable and animal membranes act as a semi-permeable membrane. The most important semi-permeable membrane used in our life, these are known as pig bladder. What? Pig bladder. But certain artificial materials must be also used, such as cellophane and parchment paper. So these are the concept about osmosis and osmotic pressure. For discussing about the next thing, law of osmosis, we must be discussing next class. Till goodbye student, and thanks for listening this lecture about the topic collegative property osmotic pressure. So remember part, you must be wait in the next video. Okay, goodbye. Thanks.